Stoichiometry begins with a balanced chemical equation. Here, the coefficients tell us the exact molar ratio. 2 moles of hydrogen gas react with 1 mole of oxygen gas to produce 2 moles of water. A limiting reagent is the reactant that is completely consumed first, stopping the reaction. Just like making hot dogs, the ingredient you have the least of, relative to the recipe, determines how much product you can make. To find the limiting reagent, we first convert the mass of our reactants into moles. We divide the given mass by the molar mass found on the periodic table to get a standardized unit for comparison. Starting with 10 grams of hydrogen, we divide by its diatomic molar mass of 2.02 grams. This gives us approximately 4.95 moles of hydrogen available for the reaction. Next, we calculate the moles for oxygen. 40 grams divided by 32 grams per mole results in 1.25 moles of oxygen. Even though the mass was higher, the number of particles is lower. Now we compare these amounts using the mole ratio from our balanced equation. To react all 1.25 moles of oxygen, we only need 2.5 moles of hydrogen. Since we have over 4 moles of hydrogen, we have more than enough. Because the oxygen will run out first, it is our limiting reagent. The hydrogen is the excess reagent because some of it will remain unreacted after the oxygen is gone. The theoretical yield is the maximum amount of product that can be produced. It is always calculated based on the limiting reagent. Here, our 1.25 moles of oxygen can produce 2.5 moles of water. To find the mass of our product, we multiply the theoretical moles by the molar mass of water. This tells us that, ideally, this reaction should produce 45.05 grams of water. In a real lab, you might get less than the theoretical yield due to spills or incomplete reactions. We measure this efficiency using percent yield, which compares your actual results to the mathematical prediction. To summarize, always start with a balanced equation, convert your masses to moles, identify which reactant limits the process, and then use that reactant to calculate your final theoretical yield. By following these stoichiometric steps, you can predict the outcome of any chemical reaction with precision. Generated by Vision Solve AI.